Reactive Microservices. My name is Martin Stefanko. I work as software engineer at Red Hat. I'm a big MicroProfile fan. I'm also a MicroProfile committer since August this year, and you can find me on Twitter on the handle Stefank. Today I'm going to talk about how we do reactive in MicroProfile, and I would like to start with a quick story, or better, the reactive story. It all started long time ago in 2014 with Reactive Manifesto, where a group of independent companies came together and identified a set of properties that we can find in modern, robust, and resilient microservices applications. They call these applications reactive systems. And these 4 properties that they identified was asynchronous message passing. That basically means that the communication between your services needs to be decoupled through basically a name channels. That means that you are always sending asynchronous messages to some virtualized address. What this in turn gives you is directly elasticity, so you can scale the services behind this virtual address, and you have some form of load balancer that is just distributing the messages, and resiliency, because if there is no service behind this virtual address, the channel itself or the publishing site can somehow buffer the messages and resend them if needed. Basically, asynchronous messages always needed to be acknowledged. So unless there is an acknowledgement, the message will be resent again. All these 3 properties together will give you together a responsive system, and this is the most important emphasis that the reactive system put on. Because if you don't make responsive system, what will happen? Well, basically, the long answer is in the Reactive Manifesto itself, but the short answer is that we all know what the users do if your system is not responding. And then it's a different kind of story. So after reactive system and these properties, we came up with an idea that maybe we can expand on this, and we identified that we are already doing this in one form or another in many different forms, and we call this collectively reactive programming. So you are probably familiar with Fibers or Project Loom, which is coming in next versions of Java, event-based system like message-driven beans, or even Excel spreadsheets when you can set one table to be updated every time some other table is updated, other cell is updated. So basically, what these all things have in common is that they are reacting to change instead of creating the situation itself. So we are reacting on receiving the message. We are not requesting a message to be received. What they all have in common is that they need to be non-blocking, because if you block in anything that is asynchronous, you are basically degrading back to a synchronous system. From reactive programming and these non-blocking ideas, a few years back, another group of companies led by Lightband came with the specification of a really simple API called Reactive Streams. Basically, Reactive Streams are 4 Java interfaces that are able to define non-blocking data pipes with back pressure. That means that we have now some publishing side connected through a pipe to a receiving or subscribing side, and the only form of communication is done through this pipe asynchronously. What the back pressure means is basically that the subscriber can tell to the publishing side that I'm not able to consume any more messages until I process what I already got. And after I am finished with my processing, I will tell you that you can continue publishing again. These 4 interfaces that there are in reactive streams are publisher, publishing side on the pipe, subscriber, receiving side. Processor is something in between. It's able also to consume messages and also produce them. And subscription is an object which is linking basically publisher and subscriber. Since Java 9, all of these interfaces are actually part of the JDK itself in Java util concurrent flow class. So basically, the communication in reactive streams is pretty straightforward. As a first request, there is a subscribe call on publisher with the subscriber instance. Publisher in turn must invoke onSubscribe callback on a subscriber in which subscriber received the subscription. The subscription has only 2 methods. One is for canceling the receiving, and the second one is for back pressure, and this one is called request, which is taking a single long value with a number of values that the subscriber is telling publisher that it's able to receive. So if we request two values, publisher is then requested to invoke on the next callback on a subscriber 2 times with different published values. This can happen several times, always only the allowed value of requested, which subscriber is sending, until subscriber requests more values that there are actually present, or there is an error. In that sense, the subscriber will receive on complete or on error callbacks, which basically terminates the stream and terminates the communication. Pretty simple. Like, this whole API has together around 10 methods. So it's simple Java API. We can implement it. Actually, there is several good articles on the internet why you shouldn't do it yourself. But there is also a TCK for this Reactive Streams API. So if you are willing to do that, I would say go, give it a try. But to get it right, to pass this TCK is really hard. So from Reactive Streams, basically, we needed some form of abstraction on top of that, because if we are only subscribing to values which are published, there is nothing really much there is nothing that we can really do with it. We are just receiving the values that are being published. So another group of companies came with an idea to create something which they call reactive extensions, which is expanding on reactive streams, providing the implementation of the publisher and subscriber, for instance, and also giving you a set of operators that you can use to manipulate these streams, like basic operations from Java 8 streams, like map or filter. And the most known ones are RxJava, Flowable class, or Project Reactor in Spring, Flux, or Mono. So maybe you already are using these and you maybe even don't know it. And MicroProfile basically comes somewhere between these two, because it's building on top of reactive streams, but it's also providing something similar to reactive extensions. And this is what we are going to talk about today. So MicroProfile Reactive is actually, or consists of two specifications. The first one is Reactive Streams Operators, which is a Reactive Streams class plus the set of operators like map. And the second one is called Reactive Messaging, which is a development model based on CDI beans, which you are able to connect throughout the reactive streams. And we will go through both of them, but I prefer to show you this in an IDE. So I will create now a new project with Quarkus called MP Reactive. And open it in IDE. Oh, come on. Yeah, I need to change first. And open it in IDE, and I will put Quarkus into a dev mode so we can see the live reload. Sorry, I need to close a few things. And let's open the generated class. So for starters, we will start with just reactive streams operators. This is a really simplistic specification, which is more targeted as a base for reactive messaging. So what it provides us with is basically this reactive, and I'm sorry, I didn't include it because in Quarkus we have this form of extension. So I need to actually include reactive streams operators as an extensions to actually get this functionality in Quarkus. Sorry about that. And let's return to the dev mode. Now, if I enable auto import, I should get a reactive streams class. Come on, idea. No? Oh. Oh. Oh, come on. Live demos. And now when it's running, idea should be happy, and I can return reactive streams. Reactive streams, I still can't. Ah, now I can. And I will be using reactive streams off. So basically, this is really similar to Project Reactor or to RxJava. So if you are familiar with it, this is just like unified naming on top of that. So I can create the stream with directly some default values like uppercase. There was a new Star Wars trailer yesterday. Let's do Kylo. And then you can play with this kind of stream that is going to be published. So my stream is really simple. It's going to only publish 3 values, but I can directly use operations that you are used from Java 8 streams. So I can, for instance, map everything to uppercase. I can filter only ones which are shorter, let's say, than 3 characters. And then I can collect everything to a list. And what this gives us back is something which is called completion runner, which has only one method, run, which will return a completion stage. And this we can directly return from our JAX-RN endpoint. Users are typically not required to call this run method themselves because the framework will run them for them. So if I now invoke this endpoint, we should get back only 3 long characters in uppercase. So this is the basic idea of reactive streams. Really use these reactive streams as an entry point and build whatever reactive streams classes that you will need. I can also show here, just to see something different, there are also a bunch of from methods which are taking, for instance, reactive streams publishers. So I can create here some publisher instance. And this will be publisher. Let's publish strings. And I can, for instance, use RxJava here. So I can use reactive streams as a specification that unifies these two. I don't have flowable. Interesting. So I can't because I don't have flowable, and I should have. Okay, never mind. Or this is not the right publisher. No, it is. Yeah, but I should have RxJava coming with, but my idea is making fun of me. Really, live demo. So I have it here. So let's just publish every second. This will give us a long, so let's just map it to string. Yeah, to string. So I'm now creating RxJava publisher, but I'm plugging it into a publisher of reactive streams. Now we don't need this mapping, and we can collect these two lists because actually this will produce values every second. So let's just create also a subscriber. And as I said, this is a really hard thing to do, so don't try this at home. And I will do a new subscriber of, let's just print here M, and we will save subscription, which we received. Yeah, this will be a subscription, and we will request one element. In our next call, we will just print the value that we received, and again, we need to request another value if we want to continue continuously. On error, we can just print this error, and on incomplete, we will print that we are completed. And yeah, sorry. So this looks good up to the point that this is now going to run indefinitely, so we are unable to return anything, so I can just do void here. And now if I type everything right, when I we received our unsubscribe, and every second we are getting values. So this is really this pipe that we are connecting now publisher to a subscriber. So this would be really the simplest possible example of reactive streams operators. And let's continue with reactive messaging. So as I said, reactive messaging is basically a specification that allows you to build these individual parts in CDI beans and interconnect them throughout your application or your microservice. So in the beginning, we have some CDI bean, which is defining some publisher who is publishing some values to some channel. This can be directly consumed in some different CDI bean, which, for instance, only do some map operation and continuously up to the point it is received by some CDI bean which will consume them. So there is a subscriber on the other end. Because all of the CDI beans are always on one microservice, you are probably wanting to put this reactive architecture throughout your all microservices deployment. So what MicroProfile Reactive Messaging also allows you to do is to consume the stream directly from somewhere outside of your service, outside of your system, and also produce it somewhere else. To do this, there is a motion of a connector in MicroProfile Reactive Messaging, which is basically a class that you can implement yourself. It needs to implement two interfaces, which basically only create a publisher builder and subscriber builder, which are classes in Reactive Messaging, which are transforming the messages from your external services to something Reactive Messaging can understand. So then your users are just able to plug these connectors directly into their microservices, and you can, for instance, consume messages directly from Kafka and push them on the other end to an IMQP. From a user perspective, what really MicroProfile Reactive Messaging are only two annotations. The first one is outgoing, which is taking one required string, which is the name of the channel that you are going to consume messages from. And the second one is incoming. Oh, sorry. You are going to produce messages. And the second one is incoming, which is defining the channel which you are going to consume. You are also able to combine these two annotations to define reactive streams processors. And I want to point out that in all of these examples, you can notice that we are always processing only a single message. So basically, this method is going to be invoked for every value that is going to be produced in my incoming channel, and it's going to produce exactly one value to my outgoing channel. There is also an option to work with the whole stream if you prefer to define your map and filter operations on that. And with that, I will get to my last demo, which will be a coffee shop, which we are going to start with a basic HTTP coffee shop, and we will see what the issues with synchronous and blocking calls are, and we will try to rewrite this to a messaging. So what we will start with, that we have our user who are making HTTP calls to our front-end coffee shop service, which in turn makes a HTTP request on our backend service, which is Barista, which is actually responsible for preparing the coffee. So if a user requests a coffee, the call is propagated in a blocking manner to a Barista service. Barista will take some time, which is randomized. After the coffee is prepared, the HTTP call just returns the response, and this response is propagated back to users. So you would say that user is happy because he got the coffee, but actually he is or she is not, because they needed to wait for the whole duration of the request. So you can imagine that you will come to a coffee shop and you will order a coffee and you will stand there for 5 minutes until the coffee is prepared. So what will happen when actually Barista went down or takes a break? So again, somebody requests a coffee. The call to the Barista service will fail because there is no Barista, and we will just return this error to the user. So user is, again, not really happy because I just can't order coffee anymore. And I have this prepared, so let's try to take a look. I have this kind of naming. I hope that it's readable. So I will start my coffee shop service. I will start my, oh, sorry. Come on. And what? Sorry. Maybe I need to compile it first. So I will start my, hopefully, coffee shop service. Yeah, it's running. Let's start our Barista service, which are still based on HTTP. And what we are able to do now is actually to make this user request. We are requesting a coffee. If you're not familiar with HTTP, this is just invoking localhost/HTTP, sorry. And this product and name is going to be concluded in a JSON format. So we are sending JSON with two properties. And if we send the message, it was received in our coffee shop front end, propagated to Barista, and after Barista was ready, maybe it was too fast. Now it's preparing coffee, it will just say that the coffee is ready and the call is returned back. As you can see, for the duration of the request, as it is randomized, my client is blocked. I cannot do anything with it. If I now kill the Barista service and try to order coffee, we will get a really nice error to the users, which users definitely know how to decode. So let me stop these services, and what I'm going to do now is actually rewrite this service really quickly to reactive messaging. So we will still have our users which are making HTTP requests to our front end, but this time we are not doing back to the backend HTTP request. We we will be using messages sending to an Apache Kafka through two different topics. The first message is sent to queue topic, which will be, we will directly return, so we will be not blocking anymore our clients. That means that we are making actually responsive system. The first message is going to be propagated to a queue, which will be displayed on a board, which users can read that my coffee is still being prepared. And the second order is going to be consumed by a barista service, which will take, again, its time to actually prepare the coffee. And when the coffee is ready, he or she will, again, push the message to a queue service, which just change the state of the coffee on a board that the coffee is prepared. And users can asynchronously read that the coffee was prepared from the board. So this is more similar to a Starbucks model. So you will order the coffee, they will give you some ticket, you will go sit somewhere, and when the coffee is ready, they will just notify you asynchronously that the coffee is ready so you can pick it up. You are not standing at the counter. So let me try to actually implement this. So here I have our microservices deployment open in IDE, and we will start by changing our coffee shop resource. As you can see here, we only have one HTTP endpoint, which is our blocking HTTP backend call. If you are familiar with MicroProfile REST client, this is basically only definition of REST invocation. So this will block until exactly as we saw previously. So what I will do now is to add a new endpoint, and we will call it messaging. And I will write an asynchronous and responsive endpoint that will just propagate messages to the Apache Kafka, which I got running in the background. So now I cannot return beverage because I will not have beverage ready in time. So let's just create something which will return an order, and we will also take an order as an argument. That's the JSON that I was sending from a command line. I can actually use the same because we will need to, come on, I cannot use this. Oh, but it's somewhere hidden. Okay. I will copy paste because I cannot see the window which will refactor to a method. We will need to again set the ID on the order. We will print it to the standard output, but here we will send messages to Kafka. We will not make an HTTP call, and since we don't want to block this method anymore, we can directly return an order so the user has something to confirm that the order was received. To actually send messages to Kafka, we need to first configure our connector, which is quite a maybe more or less configurations that we need to put into our services. I will just save time because it's a lot of typing. Basically, this is the standard format how we could configure any reactive messaging connector or any basically messaging reactive channel. It's always MP messaging, then it's incoming or outgoing, depending on what you are going to do with the channel. Then it's the name of the order, and then it's concrete values that you are going to set. As you can see, all of our example is going to go through Kafka. Small Ray Kafka is an implementation of the connector, and we will be sending string messages. So I can see here that I will be sending outgoing to two topics. One is called order and one is called queue. So if I want to use this, I can use CDI since this is a CDI bean, and I can inject directly the channel itself. And again, IDIs, and yeah, I forgot again to add the extensions, sorry. So again, with Quarkus, if we want to start using some functionality, we first need to add it as an extension. So what I'm adding here is reactive messaging and the Kafka connector. And I will actually need to add it into both of the services. You can see that it was added successfully. And if now I go back, I should have channel, and I don't. Come on, idea, now I have. As a channel is a custom annotation for small array which allows you to bridge synchronous or blocking world with the reactive. So if I want to publish messages to Kafka from a blocking HTTP request, I need to inject the channel itself. And I know the first one was called queue. And what I will be injecting is an emitter object, which allows us to send the messages to the channel. And I will do the same for our topic orders. So I can inject orders. Since I will be marshalling JSON, I will also inject JSON-B, and JSON-B is now Jakarta specification that allows us to change or exchange Java objects to JSON representation. So I will do just JSON-B. Okay, so we want to send our messages to Kafka. First thing that we want to send is a message to the board that the coffee is actually being prepared. For that, I have a helper class which will just say order is queued. Come on, order. This is a helper class that will just marshal JSON with some specialized property, which is then recognized on the front end. Our second message needs to be sent to an orders queue. And here we need to use actually JSON-B to marshal the JSON to a string representation ourselves. So I just called to JSON order, and we should be good to go. In our front end, one last thing that I need to do is to create our dashboard, which will be displaying something in the front end, because that's only a simple HTML. And for that, I will use server-sent events. So this will be available at queue, and we will be producing media type, and not this media type, as SSE. And again, come on, idea. Like this? Yes. So, and this will be actually publishing. I know what I did wrong. I forgot it. It will be publishing throughout the JAX-RS publisher, because JAX-RS is able to bridge directly Reactive Streams Publisher to servers and events. So we know that we will be publishing strings from our get queue, let's call it that. And here I would like to return the queue itself, and for that we can look into our configuration. We have one incoming channel called now beverages, which is still defaulting to queue, just we can recognize that this is an incoming channel. So this is actually consuming from the topic queue into a channel beverages. So if I now want to use this channel, I can again just inject channel, but this time it's called beverages. And this time we are not going to produce value, so we need to inject something different. And we can also directly inject publisher, but for the time being, I would like to inject rather specialized form from Reactive Messaging, which is called Publisher Builder, because I want to log these messages as they are arriving. So let's call this queue. And here we can just return queue, but first I want to peek at every message that is being received to this queue, and I will just print it to standard output, got process. And now I can build it as Reactive Streams implementation, and that's it. So that would be everything for our front end. What we need to do to actually change our backend barista, who is now defined with only blocking post endpoint, to actually make this endpoint work in a reactive way. So I will actually change only this endpoint to now, or first let me start with, again, a bunch of properties that I need to put into our properties file. In this case, is a little bit more properties, because here we are really configuring Kafka itself. Everything after what is especially specialized for MicroProfile Reactive Messaging are settings that are going to be passed to the Kafka. That's why there is a little bit more of configuration here, but this is already available online, so this is not something that you will type every time. This time we are not going to be injecting any channels. We are going to use that incoming and outgoing annotations directly. And since I always forgot how these are called, we are going to be consuming from an orders, and we are going to be producing to a queue. So I know that I will have incoming messages from orders, and I will be outputting to a queue. Since now we are working with Kafka and we are serializing everything into a string, we need to change this method signature to actually consume and produce strings messages. And this method is going to be invoked for every message that is going to be produced into an orders topic, and we are going to produce exactly one message to a topic queue. So this can be again the same. We first need to deserialize our order from the message because we are sending it there from the front and we know that it's a JSON representation in string form. So we can again do JSONB. Let's just do it differently this way just to change things. JSONB, and since I can only have the default one, I can create it myself. And I can now do JSONB and call the other form of method from JSON, which will take our message, and we know that it's serialized order class. So now we have our order, and the last thing that we need to do is to publish a message to our topic queue. So now it's not going to be beverage, but it's again to be a preparation state, which is a helper class, but this time it's we already know that the beverage is ready. So we can just say here order and the created beverage. And that's it. That's everything that we need to do to change from HTTP to reactive. So if I now restart these services again, and I didn't make any silly errors, now we should be able, come on, do I have Kafka running? No, I don't have Kafka running. Okay, sorry. So let me just start Kafka and also create only one of the topics that we are going to use because I want to show you scaling. So we need to some specialized settings for a Kafka for the orders topic. And now if I start services, they shouldn't have problem to connect to a Kafka. What? Okay, that looks better. And now if we try to invoke that new endpoint that we created, you see that it returned immediately, but the coffee was preferred just now. So I can queue several messages and you see that my service is responsive and the coffee is still being prepared in our barista service. There is actually this front end that I was talking about, and let me just pick this out to what I am showing you here. So basically we have our queue here. So if I now enqueue some order, we should see it here in queue state, and after our barista will prepare it, it is transformed to ready. So our frontend is consuming from the topic queue, and it's directly displaying the messages. We can also see them logged in our frontend service. So going back to my slides, just really quick. I don't really have time to show it now to you, but since our messages are now queued in orders topic, what will happen if we kill the barista service? They will just stay in a Kafka, and when barista comes back again, it will continue consuming messages. What the Kafka, this decoupling also allows us to do is to scale baristas on the background, and if they are not able to consume messages in a timely manner, they will just start some round-robin algorithm on the background. And this is basically it. Like really, you saw how easy is it to move from a synchronous and blocking HTTP way of processing to a reactive way of defining things. It requires a little change of mindset of how we think about defining our software, but it's not something that we are not doing already nowadays. So if you like what you see, both of these specifications are available as open source. We are encouraging anybody to contribute. So if you think that this would be useful for you, or you have some ideas how to improve this, just go to GitHub or find us on Gitter. Any ideas are welcome. This would be everything from myself. And if you have any questions, I have 1 minute. Go ahead. It depends if you have that serializer and deserializer, but you can implement it yourself. And sorry, I should have. If I can strongly type serializers and deserializers, that was the question. Anything else? If no, thank you for your attention, and hopefully you like what you see.